functions here. Mariana, what'd you get for f? So I'm asking you to find the domain. Repeat that again. Okay. Regina, what did you get for the domain for this one? A negative one. Okay, it's going in the right direction. Class, your choices are not equal to 0, greater than 0, or greater than or equal to 0. Count on 3. 1, 2, 3. You're setting this one greater than or equal to 0. We've talked about finding domain algebraically. You take what's inside the radical. If you subtract 1, you would have gone x is greater than or equal to negative 1. What does that mean in interval notation? If you kind of just drew yourself a number line, it's helpful to get a visual. I need numbers that are bigger than or equals to negative 1. That would have been bracket negative 1 to infinity. Raise your hand if you got that. Good. So what does that mean? It basically means that if you pick negative 1 in here, class, what's negative 1 plus 1?
0.
And square root of 0 is? 0. I can't pick negative 2 because negative 2 plus 1 is negative 1. Square root of negative 1 is?
I.
Complex, or I. So I have to pick numbers that are bigger. Okay. Marianne, did you get this one? So here, if you just drew your graph, you have a cubic function, right? 2 sets of arrows, class, that's what? Which one's more restrictive? Left or the right? The right. This one's like go to sleep at 7 o'clock. Does that make sense? That's a restrictive parent. Question?
So the one we just found, the bracket negative 1, was for number 2, right?
That's for g of x. We're okay?
Yeah.
All right, these are going to come back into play later on. All right, so let's apply the math operations. It basically tells us to add f and g together. So let's do f in pink and g in yellow. So I have x to the third. I'll put that in parentheses, and my math operation is adding. And I have here the square root of x plus 1. I don't need the set of parentheses because I'm adding here, right? And basically my answer is x to the third plus the square root of x plus 1. Because this is inside the radical, that one's not, so you can't really add them. Okay, question. Which one is the most restrictive domain? Most restrictive domain. Which one?
Yellow.
The yellow one.
So I'm going to write that. So we can write with domain bracket negative 1 to positive infinity. That's my answer. Okay, let's try another one. Now we just need to do what? In part B. We just need to subtract them. I see the classic mistake. This minus sign. Remember, when you do your substitutions, you're going to put them in parentheses. So this will be x cubed, parentheses, square root of x plus 1. Well, I have nothing to distribute to. Do you see this? You can't distribute inside the radical sign. So my answer is x cubed minus the square root of x plus 1 with a domain of what? Which one's the most restrictive?
The yellow.
Yeah, the yellow one. So negative 1 to infinity. Alright, so it says given f of x equals 2x plus 1 and g of x equals 4x squared minus 1, find each function and the domain. I'm not sure if we had time yesterday to talk about the most restricted domain. We've been learning about the 12 basic graphs in Chapter 1, Section 3, and that's just basically a linear. So if you have two sets of arrows, the domain is going from left to right, so that'll be negative infinity to positive infinity. Basically it says you can pick any number for x. That's our domain. Did we talk about the most restricted domain yesterday? Yes? No? Okay. In 4x squared minus 1, the parent graph looks like a parabola. And because it's a parabola, you have two sets of arrows, so the answer is, the domain is negative infinity to positive infinity. So if you haven't learned or picked up at that trick, if you have two sets of arrows from the left side, it's coming from negative infinity to positive infinity on the x-axis, so I could pick any numbers. So it's kind of like your mom and your dad. Usually parents are different. Sometimes they're the same. This one is not really restrictive. This one's not really hard on you. This one says, oh, you can pick any number. You can come back at any time of the night, and I'm going to leave my wallet on the dining room table, and you can take as much money as you want and buy whatever you want. And then the other parent, they do the same thing. So there's really no restrictions on these parents or on these graphs. Okay, let's apply the algebraic. So here is plus. I color coded them for you. So this says f of x, and I'm just going to put in here 2x plus 1. Zoom in. And in the pink, I'm going to put in parentheses. Everyone say parentheses. Very important. Class, with the plus sign, do I need the parentheses? No. Now I can just combine like terms. 2x, does it have any like terms? No. How about 1? Negative 1, and that equals what? 0. And then I'm left with 4x squared. Does that have anything to combine with? So our answer is 4x squared plus 2x. And then we add this part. With the domain, which one is the most restrictive? Which one's the most strict? Well, they're the same. In this case, you can just write negative infinity to positive infinity. And this is our answer. Alright, number 2. F was 2x plus 1, 4x squared minus 1. I know it. One of you forgot to distribute the negative to both of them. 2x plus 1, negative 4x squared plus 1. Write them in descending order. Negative 4x squared plus 2x plus 1. Raise your hand if you got that. Plus 2. It says 2. You don't see that? And we forgot our domain. I was wrong. Raise your hand if you got that. Nice. To find the domain for each of these in yellow and pink. Ryan, the domain for the yellow is? Lisbeth, the domain for the yellow is?
Is it negative infinity, positive infinity?
Yes. Raise your hand if you got that. You should have just had a basic graph on in your head. Well, that's quadratic. And domain means which direction? Left to right. So it's touching an arrow, touching an arrow. Anytime there's two arrows, the answer is? Negative infinity to positive infinity. Okay? Now if you graph this one, what does your graph look like? Curve from where? From negative 1, right? Like this? Does that make sense? Okay. You guys are very visual, but we've already done this algebraically. You take your radicand, the number inside there, and you are setting it equal to, not equal to 0, greater than 0, or greater than or equal to 0. Greater than or equal to 0. If you subtract 1, you would have gone x is greater than negative 1. if you did a quick number line at -1, it is bigger. Yes? So in interval notation, your domain would be bracket -1, comma, infinity. Raise your hand if you got that. Alright. Those are going to come back into play later on. Okay? So, that was our review of what we've been learning. Hopefully the puzzle pieces are coming together. Now in our composite functions, we are to add them. Well, if I add them, all I have to do is a substitution. F of x is equal to x squared. Make sure your substitutions are in parentheses. Our g is the radical of x plus 1. Because you're adding, you don't need the parentheses anymore. Here I have a radical and this one's not in the radical. They're not the same, so you can't add them. So your answer is x squared plus the square root of x plus 1. Zoom in there for you. Now, let's think about our domain. This is the parent who doesn't really, they're really not a parent, right? You call them a parent, but they're like your brother or sister. They don't really take care of you. They can let you do whatever you want. There are no restrictions. You can come home at 3 o'clock in the morning. Here, my wallet's on top of the kitchen table. Take whatever you want. This one says there's restriction. You come home, you do your homework, and you're not eating dinner nor smartphone until you're done. Right? So this one's the most restrictive domain. You can write that. MRD. Klaus, what does that stand for? We started talking about that yesterday. So when I'm picking these, I have to pick the one that's most restrictive. That's this one. So you can write with domain of -1 to infinity. Okay? And that's my answer. So we're just applying the math operations and applying the domain. Let's try this one down here. F minus g. F is x squared, and then we're subtracting, so parentheses, and then g is square root of x plus 1. Now, you're not going to do anything crazy like trying to subtract this x from inside. They're not the same. So they're not like terms. So it's basically the same. X squared minus square root of x plus 1 is our answer. And what is the most restrictive domain? Which one, Klaus? Which one has a stricter parent? Bracket -1 to infinity. And that's our answer. Alright, let's do the one that has g times g. G is the radical x plus 1 and times radical x plus 1. Question. They're in parentheses, yes? How many do you have of these? There are 2 of them. Let's write them together. Let's see if we can simplify it. So if we did a simple problem like this, if I said the square root of 9 squared. Klaus, what's the square root of 9? And what's 3 squared? 9. It's just a number inside. They kind of cancel. Do you see that? So in this problem, what's our answer? It's just x plus 1. Actually, this problem we can't do that. So we'll just keep it as this one. Can't cancel there. That's the answer. What's our most restrictive domain? It's the same thing as above. I'll tell you the restricting domain only changes when we get to the fraction one. Okay? Only when we get to the fraction one. So, find the following below with their domain. These are called function compositions. Every time you see f of x, or every time you see the f, we're going to write x minus 3. So let me do that for all of them. F of x, x minus 3. And you should be doing your substitutions there. You can see in parentheses. And then every time we see g of x, we're going to write x squared plus 9. G, 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 x squared plus 9. And anytime you evaluate or you're going to do a substitution, you need to put them in parentheses. So students who got this problem wrong got no parentheses. I put in my substitutions there. Notice here this is a plus sign, so you don't need the parentheses. Drop them, combine like terms, x squared plus x plus 6. And the domain is negative infinity to positive infinity. Let me explain that. You're supposed to find the least restrictive domain. Find the parent, right? You're a kid. You try to go around your parents. You're going to ask the parent who's more lenient, right? So if you need money, go to the one who usually gives you the most money. So notice how these parents or these domains are exactly the same. So then your least restrictive domain is just this, negative infinity to positive infinity. For question number B, remember the substitution is in parentheses, and when you have the subtraction sign, it's a negative 1. So you have to distribute. That would become negative x squared, and this will become a negative 9. And when you combine like terms, you get negative x squared plus x and minus 12. Same thing with the domain of negative infinity to positive infinity. Alright, on the back side here, I have f of x and g of x, and the back side of your response, make sure you show all your work and box your answers. So, find the following along with their domain. So, the domain, remember you're going from left to right, and here you have a linear function. So the first thing I touch is an arrow on the x-axis from the negative infinity to positive infinity. So you can domain here is negative infinity to positive infinity. Remember the trick is if you see two arrows, then it's going to be this. X cubed, your graph looks like this. Two arrows, same thing. Question number 1 says function of f plus a function of g. So f of x equals 2x minus 5, and you're going to basically add 2x minus 5 plus a function of g. So this would be x to the third. So you'll notice that there are no like terms here. So I can just put that in descending order, x to the third plus 2x minus 5 with a domain from negative infinity to positive infinity. And this will be our answer. Question 1b tells us to subtract a function, so f of x minus g of x. F of x is 2x minus 5 minus g of x, which is x to the third. I'll take the inverse of that, so that becomes negative x to the third plus 2x minus 5 with a domain of negative infinity to positive infinity. For your response, make sure to show all your work and box your answers given f of x equals x plus 2 and g of x equals x to the third power. Find the following along with their domain. So I'm going to go ahead and find the domain of each of these. And if you need a graph, go ahead and graph it. X plus 2 is just a linear. Remember, domain means going left to right. You're going from left to right here. You're starting on the x values that are negative infinity, and the x values are positive infinity. So don't think it's negative infinity because it's pointing down. You could have had the slope like this, and that would be negative infinity to positive infinity. And then x cubed, our graph looks like this. Same thing, negative infinity to positive infinity, because you have your two arrows. Find A tells you add f to function of g, so x plus 2. Remember when you're doing your substitution, put in parentheses and x cubed Notice how these are not like terms, and we don't need the parentheses because of the plus sign, so I can write this in descending order, meaning looking at the exponent. X to the third, x to the first, 2x to the 0, with a domain of negative infinity to positive infinity. And basically here you're just looking for the most restrictive domain. Which parent, which one has the most restrictions? Which one is more strict? Alright, let's do a subtraction. Function of f subtracted by the function of g. So x plus 2 minus x cubed. And again, they're not like terms. Here I can distribute the negative, so this becomes negative x cubed plus x plus 2, descending order, with a domain of negative infinity to positive infinity.
For your response, make sure to show all your work and box your answers. Given f of x equals 2x squared minus 5 and g of x equals x minus 3, find the following below along with their domain. Okay, so we'll do the domain last. I'm just going to substitute every time I see the function f. I'm just going to write 2x minus 5. Here's f, 2x minus 5, f, 2x minus 5. And notice when you're doing those substitutions, you're doing those in parentheses. Oops, I'm putting markers in. And then g of x is x minus 3. Again, I want you to notice that I put my substitutions here in parentheses. Well, I lied, most of them. This one I forgot. But you'll notice that it doesn't matter in this one here. Let's do the first example. This one says f plus g. So with addition, you don't have to use the parentheses, so you can drop them. So 2x squared, there's no like terms. There's a positive x, and negative 5 and a negative 3 gives you negative 8. Okay? To get the domain, basically what you're doing is you're adding the two functions together. So if you look at their domains, you're looking for the least restrictive domain. Well, 2x squared minus 5 is basically a quadratic. And if you go left to right, then you have a domain of, you can pick any number from negative infinity to positive infinity. G of x equals x minus 3 is a linear equation, same thing. Going from left to right, you have arrow to arrow. That means you can pick any x value. So to get the full credit for this problem, it would be the domain with a negative infinity to positive infinity. Let's look at B. Now look at what happens if you don't put these in parentheses. 2x squared minus 5 and x minus 3. You're going to have to distribute that negative sign. Another way of thinking about it is a negative 1. So it's negative 1 times x gives you negative x. And negative 1 times a negative 3 gives you a positive 3. You combine like terms, you get 2x squared, negative x, and a minus 2. Same thing, you're looking for the least restrictive domain. Since they're the same, then you'll have negative infinity to positive infinity.
I had to divide to get it right. I'm really playing chess. I use my knife, can't fall behind. I got it right, don't sleep in class. Oh, you won't pass. I use my formula sheet, cause I don't cheat. I use it on my test. I'm feeling blessed, rose for Christ. You gotta come, remember in class, we don't chew gum. Get off your phone and pay attention. Not to mention, you're your detention.